Hello everyone. When you look at Greenland on a map, it's easy to think you already know what it is, a huge white island in the far north. But the part that changes the story is what sits under the ice, and what that ice is sitting on top of. Before we dive in, make sure to subscribe, hit the like button, and enable notifications to stay updated with our future videos. Welcome to Midnight Questions, where curiosity meets the unknown. Beneath Greenland's ice sheet, researchers have identified a bedrock canyon at least 750 kilometers long. It was invisible for most of history, and only became clear through ice-penetrating radar and modern mapping. In northwest Greenland, under a glacier, there is also a circular impact crater more than 31 kilometers wide. These are not small details. They help scientists understand the shape of the land under the ice, and they can influence how meltwater moves beneath the ice sheet. Once you move from hidden landscapes to hidden materials, Greenland becomes even more interesting. In southern Greenland, geological surveys describe very large rare earth element deposits. Two examples that are often cited are described at around 673 million tons of ore and described at around 4.3 billion tons of ore. Those numbers are hard to picture, but the basic point is simple. Greenland is one of the places where the rocks are already known to hold major concentrations of materials that modern technology uses. Rare earth elements matter because they show up in practical, everyday things. A clear example is high-performance permanent magnets. These magnets are used in compact, efficient electric motors and in many electronic devices and components. Most people never see rare earths directly, but they rely on systems that do. That is why rare earth supply keeps coming up in global conversations. It affects real manufacturing and real products. Greenland's mineral story is also bigger than rare earths. Geological work highlights other useful elements concentrated in certain regions, including lithium, tantalum, niobium, as well as major deposits like for molybdenum and the area associated with platinum group metals and other elements. You don't need to remember the names. The important idea is that Greenland's geology includes specific settings that can concentrate valuable materials, and that makes it relevant even from far away. It also helps to clear up one misunderstanding. Rare earths sounds like they are almost impossible to find, but that's not really what the name means. Many rare earth elements are present across Earth's crust. The challenge is finding them concentrated enough to mine efficiently, and then processing them at industrial scale. That's why these resources attract attention. It's not just what exists in the ground, but how hard it is to turn it into usable materials in large quantities. Alongside minerals, Greenland is often mentioned in connection with offshore energy potential. Large Arctic assessments have estimated that significant amounts of undiscovered oil and natural gas may remain north of the Arctic Circle, mostly offshore, and they point to offshore East and West Greenland as areas where very large accumulations are plausible. Offshore Arctic conditions are difficult, expensive, and uncertain. But it explains why Greenland appears in broad discussions about long-term resource possibilities. Now, the biggest stored resource on Greenland isn't a mineral at all. It's fresh water locked into ice. Most of Greenland is covered by the Greenland ice sheet, one of the largest freshwater reserves on Earth. The scale is easy to summarize. If the entire Greenland ice sheet melted, it would raise global sea level by about 7 meters. Another commonly cited estimate is about 7.4 meters of sea level equivalent. Those numbers are not short-term predictions. They are a way to understand why Greenland is treated as globally important. The ice holds enough water that even partial change matters. Greenland's location is the next reason it keeps coming up. It is the world's largest island, positioned between the Arctic Ocean and the North Atlantic, northeast of Canada. At a global scale, it sits between North America and Europe, close to waterways where different ocean systems meet. Oceans are not still. They carry heat, salt, and ice around the planet, and Greenland sits beside key pathways in the far north. That position also connects Greenland to changes in Arctic shipping. Researchers using satellite records have reported increasing ship traffic across the Arctic overall, especially during the parts of the year when ice conditions allow it. But it's important not to oversimplify this into the Arctic is opening and travel is getting easier. Conditions vary year to year, and even within the same season. In some places, shifting year ice can clog routes like parts of the Northwest Passage and shorten the shipping season in certain sections, even in a warming Arctic. So Greenland's surrounding seas matter because conditions are changing, and those changes affect real routes and planning. When you put all of this together, it becomes clear why Greenland is mentioned so often despite being remote. It comes down to three steady reasons: resources, location, and science. On resources, Greenland's bedrock includes large known deposits of rare earth elements and other valuable materials, and it sits near offshore basins that have been assessed for oil and gas potential. On location, Greenland is placed between major ocean basins and near key northern waterways. On science, Greenland is one of the most closely watched places on Earth because changes there can be measured clearly and tracked over time. The climate part can be explained without getting technical. Greenland's melting matters for sea level because the ice sheet stores so much. It also matters for the North Atlantic because meltwater is, and is lighter than salty ocean water. Large inputs can change surface conditions and mixing, and that mixing is part of how the ocean moves heat around the world. That's why scientists monitor Greenland closely using satellites and field measurements, because year-to-year changes in snowfall, melting, and glacier flow can add up over time. And here's a quiet way to end this. On a map, Greenland can look like empty white space. In reality, it's a place where you can see the planet's systems overlapping in one location, hidden landscapes under ice, valuable materials in rock, a huge reserve, and oceans that respond to change. The late-night question is simple. How many places that matter to everyday life do we ignore just because they're far away? And because the first signs of change show up on scientific maps long before they show up at our doorstep. If you have an idea for another video or a topic you'd like us to explore, leave it in the comments below. Your suggestions help shape future episodes.